In this video, we will discuss the significance of the correlation coefficient. We use the procedure discussed in Chapter 8 to test the significance of the correlation coefficient. State the hypotheses, find the critical values, compute the test value, make the decision, summarize the results. The data are quantitative and obtained from a simple random sample. The scatter plot shows that the data are approximately linear related. There are no outliers, and the variables come from normally distributed populations. The formula for the t-test for the correlation coefficient is t equals r times the square root of n minus 2 over 1 minus r squared, with degrees of freedom equal to n minus 2, where n is the number of ordered pairs. So for example, we'll test the significance of the correlation coefficient r equals 0.982 when n equals 6 and r equals 0.982. So the hypothesis, this is the results from the, this is the value of R that we found when we were talking about the car rental problem in the previous two videos. So the hypotheses are H naught, our null hypothesis, is that rho equals 0, and H1 is rho is not equal to 0. So it's going to be a two-tailed test. By table F, since alpha equals 0.05 and there are 4 degrees of freedom, the critical values are plus or minus 2.776. The test value is t equals r times the square root of n minus 2 over 1 minus r squared, which is 0 minus 0.982 times the square root of 6 minus 2 over 1 minus 0.982 quantity squared. We make the decision to reject the, which is 10.398, and we make the decision to reject the null hypothesis since the test value falls within the critical region. There is a significant relationship between the number of cars a rental company owns and its revenue. The p-test may also be used to find the significance of the correlation coefficient. This process is identical to that discussed in Chapter 8. So if you run into a p-test problem, refer back to Chapter 8 to figure out how to do that.